Okay, dear students, let us see what is there in this question. A particle of charge this moves from the point x to y in a uniform electric field. The diagram shows some equipotential lines on the field, and the potential is also written. What is correct about the motion of the particle from x to y and the magnitude of work done by, okay, the question is not visible, magnitude of the work done by the field on the particle. So clearly it is mentioned that we are interested in work done by the field. We're not talking about the external agency. As I have already told you, whenever the people frame a question, they should tell you, like, find the work done by whom. That has to be done. Okay, so now, as I have already told you, step number one in such kind of cases is to find the potential difference, which is the final minus initial. So what is the final potential? 700. What is the initial? 300. So we just do it, and it would be, this would be kilos. So this is the kilovolt. Now coming to step number two, you multiply with the charge and you find the change in potential energy, which is q into delta v, and we would be considering the negative signs also. So it will be negative minus 2.5 10 raised to power minus 6 multiply by 400 kilos. This is the total potential energy. Now the step number three is the work done by field is equal to negative of the change in potential energy, because in such cases we are not considering kinetic energy. We always say that the kinetic energy here is zero, kinetic energy here is also zero. We say like that. So we never think about the kinetic energy from that point of view. Okay. So even if there is kinetic energy, like in this case, there is the forces and kinetic energy will come there, but that will be coming at the expense of potential energy. So it is okay. So now the work done by this is negative. So we have to find this thing, my dear students. Let us be a bit faster here. Yeah. So this can be taken as 10. It would be 1000. It is 125. Fours are 4, 4. Everything is getting cancelled out. Only negative is left. Minus 1. So minus and minus plus. So work done is definitely plus 1 joule. So 1 joule is like this. So this is how we will find. This is the potential energy. And so work done is negative of change in potential energy, which comes out to be negative of negative 1, positive 1 joule. This is how we find the work done by the field. 100% sure, no doubt about anything. Just try to understand step by step. Try to see this thing. This is perfectly done. Okay, now let us move to the next top point, the motion of the particle from x to y. Now, what is the motion of the particle? So, my dear students, we will be concentrating at this point. Here, the potential is more. So, I can say this is positively charged. Here, the potential is lesser, so it is more negative. Comparatively, that is more negative, this is more positive. And this is a negative charge. It means negative charge is trying to move towards the positive charge. I repeat, negative charge is going towards the positive charge. Negative charge is getting repelled by the negative charge. It only means that the field force that is acting on this is also acting downwards. It is experiencing a force which is downwards. The electric field is also, this is positive and this is negative. So electric field is in upward direction. This is the direction of electric field. The force is acting in the downward direction because this is negatively charged. So the field force is downwards and the charge is also moving downwards. It means it is acted upon by a force. It means there will be an acceleration. So it is a uniformly accelerated motion and the work done is 1 joule. So the answer will be D. I repeat, the electric field is upward, the force is downward. So the charge is being acted upon by a force, and because F is equal to m into A, it would be experiencing a uniform acceleration. So the velocity is now increasing. So here the velocity is 0. Here the velocity has is attained some value, that is v. So kinetic energy has gained at the expense of potential energy, so it is losing potential energy and it is converted into kinetic energy. Hence the answer is D. So my dear students, let us see from the mark scheme, and yes, the answer is D. So this is how we do this question. This is Professor Varun. Please subscribe to the YouTube channel. Please watch this video a couple of times. Okay, all the best.